Someone on YouTube commented on my first game developer video, or rather the first video for the ECS series. They said, "Am I going to be the big meanie who asks a seemingly harmless question? Why start with SDL when you could start with Raylib instead? Why aren't you trying to make a game rather than reinvent everything? Sometimes it's wonderful not to have to reinvent the wheel, the gear, the axle, and also the horse training, feeding, carrying necessary to make a cart to move a big piece of furniture. It even starts out with fighting SDL within the first few minutes." And I say this is a valid question. I've only recently heard of Raylib, and I haven't looked into it. I'll check it out. Thanks. So let's dive right into that. So I decided that maybe today's a good day to check it out. Here's the Raylib homepage. Scroll through, and it's an interesting alternative to libsdl. It's a C-based library, pretty straightforward, just install some dependencies. And once you do that, and once you actually have Raylib compiled and installed into your system, there's a pretty nice template I was able to find. Allowed me to just quickly get something up and running without having to do a whole lot myself. I have not really gotten into why one over the other yet, but the big advertisement that I see is that it takes care of a lot under the hood for us. And it's got some interesting things that might make it easier for me to get demos out to people, as well as build for different platforms. So, because I'm all about research, I decided I wanted to check it out. Here we are building Raylib, and by the end of this part, I'll be able to link it to other projects on my system. So it's installed, and at this point I attempt to start with making my own file and realize, oh wait, I'm gonna have to do a bunch of linking and stuff. Maybe there's a pre-made CMake or something that I can use. I'm not quite there yet, but I first start by dropping in their little hello world example, realizing, oh wait, I'm going to have to link a bunch of stuff. And I can't just directly compile it right away. I get pretty lucky here though, and I discover they link to a template that I'm able to use. I'm going to link the template in the video description, as well as the Raylib homepage. So here we are getting the template. We clone it to a new folder. And all we have to do at this point is run a couple CMake commands. Right now I'm just kind of taking a look at the folder structure. I see they provide a Visual Studio 2022 template, but we're not using Visual Studio. But that might make it easier for when it comes time for us to build for Windows. There's an error in the CMake lists file involving the web string for the platform, so I decided to just comment these things out. Probably have to do a GitHub issue report or something, but it builds pretty fast, and the game is in /build/Raylib game template, and here it is. Let's slow down. Take a look at what we got here. So it comes with the title screen that we can hit enter or tap or jump on gameplay screen and a ending screen. So they've separated out different scenes for us right away, which is really nice. And it looks good. It's responsive. It seems like a good starting point, honestly. I decided to take a look around the website a little bit longer, take a look at the different games and things. Here's the raylib.h file that you're supposed to include into your source. It's pretty big. It's a lot. And they don't have traditional API documentation, but what they do have is a cheat sheet. This cheat sheet has a list of all of the different methods and functions available to you for different categories. Zoom in, let's take a look. This is all window functions. We've got init, close, should close, is ready, full screen, minimize, maximize, focus, resize. A lot of standard functionality that we would expect from any sort of windowing API. I'm not sure how I would go. See, like for instance, toggle full screen. I actually implemented that myself in libsdl. So seeing that something like this is handled for me is incredibly encouraging. We also have cursor-related functions. We have drawing-related functions, such as clear background, 2D mode and 3D mode, which is interesting. We even have a shader mode, which might make working with shaders a lot easier. Timing functions, miscellaneous functions. It looks pretty good, honestly. Lots of functionality that we're going to have to dig into and work with and figure out. And it's going to be a significant departure from the way that I think about doing things in libsdl. It's always a mammoth pain in the butt when you need to go from one way of thinking to another. And hopefully a lot of the workflow is similar. R Shapes has a lot of different drawing functionalities built in. Draw ellipse, draw ring, draw rectangle, draw line, draw pixel. And they have texture functionality as well. Lots of different image things. I decided that why not let's get ChatGPT to tell me more about the differences between libsdl and Raylib. All right, so we've got something here. So purpose, libsdl is for low-level access to audio, keyboard, mouse, joystick, and graphics hardware via OpenGL and Direct3D. Raylib is a simple and easy-to-use library to enjoy video games programming. Ease of use. SDL is considered moderate to high complexity and requires more boilerplate, which is what that guy was commenting on. Whereas Raylib is designed to be simple and easy for beginners. Language support. Both are C, and they both have bindings in other languages. API level, libsdl is considered lower level than Raylib. I've done 3D in libsdl, and it's a mammoth pain in the ass. So it's really nice to see that Raylib has something built in for 3D. Performance is both good for both of them. Raylib see, they both advertise as cross-platform, but it feels like there is less work involved to get Raylib to port to other systems than for libsdl. In fact, libsdl doesn't really advertise any HTML5 support here. So if I wanted to like build a version of my game that ran in a browser, I might have to take another approach or find some C++ to JavaScript cross-compilation thing. I think Raylib was using mscripten for this purpose, but I haven't built anything for web yet in Raylib, so we'll get there. It says that it's used for Raylib is used for hobbyists and prototyping, but if that were true, why would anyone use it? Especially when other things exist that might be faster for prototyping. Based off of the code that I've seen so far, it might be a little bit of a pain in the butt to do prototyping, but I also, to be fair, haven't even begun writing my own Raylib code yet. So in the template file, or in the template folder, I should say, in the actual source file for the Raylib template, this is what it looks like. We include raylib.h and screens.h. There's actually a lot of files in this, and a lot of my own personal demos written in libsdl, like especially the most basic of senses, it's able to be written in a single C or C++ file. Separating out everything in the way that we've done here, there is a lot more that I would have to take in to fully grasp everything that's going on here. For instance, lines 13, 14, 15, and 16, they define a game screen, a font, a music, and a sound object. And they say that these variables are shared between modules through screens.h. I don't look at that file in this video, but we're just kind of doing a little cursory overview of the source code for this template. I'm also cleaning up some of the comments so that's not so ugly and cumbersome to look at. A lot of these dashes and stuff, it's a totally different style of coding that I'm accustomed to. So we got a init window, init audio device. We assign some stuff to the objects, set music volume, set music stream, init logo screen, set target FPS, and then we have the main game loop. And then after the game loop is over, we have stuff for the shutdown process. In other words, unloading all of the different assets and then closing our devices. Similar practice that we would do in libsdl, right? So far, so good. Past the main, we have a function for changing to the next screen with no transition. So given a game screen object passed in, we have the different cases that we have to handle. So the logo case, the title case, the gameplay case, and the ending case. And we have specific functions for each one of these to unload each. We do another switch. This handles this screen rotation. They have a transition to screen function that looks like it does just some very simple variable setting. And then the update transition function, which if trans fade out is not set, then we increment the alpha by 0.05, and then we compare that against the transition alpha. They have a comment here. It says, due to float internal representation, condition jumps on 1.0f instead of 1.05f. For that reason, we compare against 1.01f to avoid last frame to stop loading. This could probably be handled slightly differently, but it works, right? It's not like the best code, but it's okay. So we have another set of switches to handle the screen transition. We update the alpha, and then if the other case is the case, then we do some real basic stuff. Then after that, we have a draw transition to draw the actual transition as it occurs. Then we have the update draw frame, which, if not on transition, then given this switch, we handle the different cases for the different screens. So for instance, for the title screen, we update title screen. Then if the title screen is finished, then we transition to the option screen. And if finished title screen returns 2, then we transition to the gameplay screen. Let's see. I continue through. We're just cleaning up some of the comments so it's not so... There's a lot of lines in this file, honestly. And if they wanted to move things into so many files, I feel like a lot of this code could have been moved into a file too, besides main. So this is the command for CMake to configure the initial part of the build. And then once that's done, you run this command, cmake -- build, and then the name of the build folder in order to actually build the game. So I go ahead and run it again here. This time you can see the FPS display in the top left. So that works pretty good. It's very intriguing. Over here I decide I'm going to check out some of the demos if I can get them to work on the web. Brickout looks like it's working pretty good. I remember when someone in high school built something like this in Java. That was a long time ago for y'all. 20 years. Some of y'all weren't even alive in 2004, right? Like, so for some reason I couldn't get the missile command demo to work correctly. But I then decided I wanted to play around with the maze game that they have here. And it's real interesting because it looks 3D. It looks like a raycaster, or similar to a raycasting engine. The controls are kind of wonky. It took me a while to figure out that I needed WASD in order to move. And the W forward key appears to move me diagonally, or like it's like forward and to the right. But then I can turn with left and right arrow keys and strafe using A A and D. This is kind of cute, right? Like it works mostly. And it's a little bit wonky controls, but if this is something that we're able to do using Raylib, then I can very easily visualize doing some interesting first-person RPG type stuff. Or otherwise, right? Like, there's a lot of potential here. So I play around, I skip forward, it's kind of fun. I check out some of the other demos. Some of these 3D ones are really cool looking. They've got a first-person perspective camera. It's all in browser. It's pretty smooth. I'm sure that if a lot of the things in here were moving around, it might not run as well, but for what they have here, it works. There's another camera perspective, looking at just a cube on the ground. This one is really interesting, right? Like, not only, like, they show that you can have two different cameras in the scene, rendering views at the same time in the same window. But something about the 3D trees is just really cute. You know? I could see myself doing something like this and playing around with it. I even have all the code for each one of these examples, which I think is phenomenal. It may not be so straightforward as to like copy and paste these into a local build, but they have a lot of demos, and they really encourage you to learn by reading the code, which I can appreciate. Here's a procedural image generation demo, where they rotate through different algorithmic generation patterns. Here's one, yeah, this one where they're rendering Japanese fonts. Pretty nice. This mesh generation's kind of interesting. You do some various warping effects. And apparently you can also load models in. Look at this. I don't know if this is from Blender or what GLTF is, but it's pretty damn cool looking. Yeah, it looked like that was a Blender thing, right? Yeah. So we could actually start doing work in Blender and start pulling stuff into our games through Raylib if we want to. Let's see. What's this? Oh, here's another demo. Just showing different rendering perspectives, and I'm zooming out and then I'll zoom back in. It's pretty good. So I definitely encourage everyone else to check out Raylib as well. It looks very promising. Like, we're going to be able to do a whole lot of cool stuff in it. And it might take some time to get up to speed if I wanted to, like, port Skull over to Raylib. But it might be worth exploring for the next project, whatever that happens to be. I might end up building some demos, sandboxes I can play around with. But until then, until next time, everyone, happy Tuesday. It's Tuesday, right? Yeah. And take it easy.